In response to DeepSeek R1's meteoric rise that led to a sharp drop in US tech stock prices, Google has released its latest Gemini models, including Gemini 2.0 Flash, Gemini 2.0 Flash Lite, and Gemini 2.0 Pro Experimental. I've tested Gemini 2.0 Pro Experimental, Google's most powerful model, against DeepSeek's reasoning model R1, and I've discovered a mixed result. Before you dismiss this as clickbait, let me show you the raw coding power, mathematical capabilities, benchmark data, and other real-world applications of these models after pitting them against each other. Let's rewind back to 2024, particularly in December, when Google introduced its Gemini 2.0 family of reasoning models, an experimental version of Gemini 2.0 Flash. The problem during the time was that it didn't get much traction. Fast forward to now, and it feels like the whole world has suddenly developed a fascination with reasoning models, largely thanks to DeepSeek. This renewed interest seems to have pushed Google to step up its game, leading to the launch of its latest models alongside the Gemini app. While Gemini 1.5 Pro, an earlier model released in September 2024, was already powerful, Gemini 2.0 Pro Experimental surpasses it in most aspects. It's better at handling complex tasks, focusing on improved factuality and stronger performance in coding and math. Gemini 2.0 Pro Experimental scored 36% in the live code bench benchmark and 91.8% in maths, surpassing Gemini 1.5 Pro's 34.2% and 86.5%. Also, Gemini 2.0 Pro Experimental delivers higher quality outputs than its predecessor. It scored 44.3% in the simple QA factuality test, outperforming Gemini 1.5 Pro at 24.9% and implying more accurate, relevant, and insightful responses. Besides, it boasts advancements in complex instruction following and function calling. These enhancements contribute to a seamless and efficient user experience, particularly for tasks that require advanced reasoning and problem solving. As a result, it had 64.7% in the GPQA or Diamond reasoning benchmark, beating Gemini 1.5 Pro's score of 59.1%. Gemini 2.0 Pro Experimental retains the impressive 2 million token context window of Gemini 1.5 Pro, allowing it to process and retain information from extensive inputs. This feature is crucial for tasks that require understanding and recall from vast amounts of data in a single request, which is ideal for software engineers and AI researchers. Like Gemini 1.5 Pro, the 2.0 version supports multimodal input, enabling it to process and understand information from various sources, including text and images. So how does Gemini 2.0 Pro Experimental perform against DeepSeek R1? First and foremost, let's compare the input context window and output limit, basing our argument on how well these models can process, retain, and return information from previous inputs and outputs. With a context window of up to 2 million tokens, Gemini 2.0 Pro Experimental shines, as it can process intricate prompts effortlessly. This input prowess is a huge plus for someone like me, who often deals with complex topics. Another standout feature is its ability to generate outputs up to around 8,192 tokens in a single response. That's quite impressive. It means I can throw a lot of information at it in one go, although there's a cap on how much it can produce in return. It can process enormous details in a single prompt, but the output is capped at a specific token count. However, it's far better compared to DeepSeek R1. In comparison, DeepSeek R1 can only handle 128,000 tokens in its context window, which sounds great at first glance. However, the downside is that it only produces about 4,096 tokens per response. So while it can take in a moderate amount of data, the results are much more limited than what Gemini offers. Ultimately, I appreciate Gemini 2.0 Pro Experimental's balance between input capacity and output length. It allows me to engage with detailed prompts without feeling restricted by the limitations of other models. It's like having a reliable conversation partner who's ready to explore any subject while keeping the discussion manageable and focused. Are you enjoying the video? Then give it a thumbs up, and I'd appreciate it if you subscribe to this channel. Also, hit the notification bell so you never miss the latest updates. Now let's get back to the video. While using the Gemini 2.0 Pro Experimental model, I observed it stands out with its seamless integration of Google Search and code execution tools. This combination allows it to provide information that's not only accurate, but also current. It's impressive how quickly it can pull up relevant data and execute code, making it a powerful tool for anyone who needs real-time information. On the other hand, I've noticed that DeepSeek R1 tends to lag a bit in keeping its data fresh. While it has its strengths, especially in certain areas, it doesn't quite match up with Gemini 2.0 Pro Experimental in accessing the latest updates or handling complex coding tasks. This drawback can be frustrating, especially if you're working with a rapidly evolving subject that requires the most current information. Overall, it's clear that while both models have their unique features, Gemini 2.0 Pro Experimental seems to have the edge, particularly for those of us who thrive on having the latest insights and robust coding capabilities at our fingertips. Before we move on to the hands-on action, I think it's crucial to take a moment to examine how these two models stack up on LiveBench, a challenging, contamination-free LLM benchmark. So let's go over the performance scores for both models across different tasks and subjects. Kicking off with the reasoning capabilities, DeepSeek R1 stands out with an impressive average score of 83.17%. This performance highlights its strong ability to tackle complex reasoning tasks effectively. In contrast, Gemini 2.0 Pro Experimental didn't fare quite well, scoring 60.08%. While it still shows promise, it has room for improvement in reasoning tasks compared to DeepSeek R1. In the coding performance, DeepSeek R1 managed to achieve an average score of 66.74%. This result indicates a solid understanding and execution of various coding tasks, showcasing its capabilities effectively. On the other hand, Gemini 2.0 Pro Experimental came in with a score of 63.49%. While it still demonstrates considerable skill, it falls slightly behind DeepSeek R1 in this evaluation. These scores provide valuable insights into the strengths and areas for improvement of the two systems. When we look at the numbers or mathematical prowess, DeepSeek R1 came in at an impressive 80.71% score. In comparison, Gemini 2.0 Pro Experimental didn't quite reach that level, coming in at a score of 70.97%. These figures suggest that DeepSeek R1 has a better performance overall in mathematics. While Gemini 2.0 Pro Experimental certainly has its merits, it seems to lag here. Now let's discuss the IF average, which represents the average performance of a language model across various challenging tasks on the benchmark. DeepSeek R1 recorded an average score of 80.51%. This score reflects its capabilities and how well it handles different challenges. On the other hand, Gemini 2.0 Pro Experimental outperformed DeepSeek R1 with a notable score of 83.38%. This difference highlights the advancements in performance that can occur with newer models, showcasing their ability to tackle complex tasks more effectively. And that brings us to the global average, where DeepSeek R1 was hot at 71.57%. It's performed well in comparison to other models in its category. Meanwhile, Gemini 2.0 Pro Experimental came in with a score of 65.13%. While this isn't too far off, it does highlight that DeepSeek R1 has a notable edge in performance. Now let's examine their coding capabilities. Let's look at the first scenario, where both models were prompted to create a JavaScript animation where the word celebrate is at the center, with fireworks happening all around it. DeepSeek R1 crafted a stunning visual that captures the essence of celebration. It showcased fireworks around the word celebrate using a joyful and festive design. In contrast, the Gemini 2.0 Pro Experimental version falls short of expectations, presenting a more minimalist take with the word surrounded by colorful splatters. It's evident that DeepSeek R1 truly shines in this comparison. In another case, they were asked to write a code to create an autonomous snake game where 10 snakes compete with each other, and the snakes must have different colors. DeepSeek R1 got it wrong this time, as its visual output shows tiny squares moving around aimlessly instead of snakes. Meanwhile, Gemini 2.0 Pro Experimental has made strides in game development by creating a proper snake game featuring 10 differently colored snakes, all racing toward the same food. It also impressively includes a scoring chart, proving its enhanced contextual understanding and reasoning abilities. Adding a grid in the background enriches the viewing experience, making it easier for players to track the snake's movements. Therefore, it's safe to declare Gemini 2.0 Pro Experimental as the clear winner for this round. And there you have it, folks. After testing the capabilities of Gemini 2.0 Pro Experimental and DeepSeek R1 across multiple features, benchmarks, and tasks, it's clear that the Gemini model shines with its large context window, up-to-date information and coding tools, and robust Pygame implementation. With its knack for generating structured and visually appealing code, it's hard not to see why many might prefer it for real-world applications. But what do you think? Does Gemini 2.0 Pro Experimental deserve the crown, or do you have a soft spot for the DeepSeek R1 reasoning model? I'd love to hear your thoughts, so make sure to drop your opinions in the comments below. If you enjoyed this video and want more tech insights like this, don't forget to give it a thumbs up, hit that subscribe button, and tap the notification bell for future updates. Thanks for watching, and I'll catch you in the next one.